This is section 8.1 sets. Before we get started, let's look at a little bit of notation. So this notation is element. So A is an element of the alphabet. This means not an element. The number 3 is not an element of the alphabet. This is a subset. A, B, and C, it is a subset of the alphabet. This is not a subset. The numbers 1 and 2 are not a subset of the alphabet. This is a proper subset. So the numbers 1, 2, 3 are a proper subset of the set with the numbers 1, 2, and 3. And this is not proper subset. Sorry about that. So you need to determine if this statement is true or false. So they want to know if 9 is an element of this set here. So we see 9 is in there, so it is an element. So yes, that is true. So let's look at 4. Is 4 in this set? It is not. So 4 is not an element of that set. All right. Then they want to know if these two sets are equal. So if we just look at these as students, let's see, I can't think of Mark, Noah, Jay, and Kayla. So is that the same as Jay, Kayla, Noah, and Mark? Those are equal. That order is not irrelevant. So whatever students we have in the class, no matter what order they're in, they are equal to the students in the class, no matter how I order them. So this statement is true. Answer true or false. All right. So all whole numbers means no decimals, no fractions, that are greater than 21 and less than 24. So if it's greater than 21, does that include 21? Okay, it doesn't include 21. And less than 24. Does that include 24? It does not. So it's only 22 and 23. So this is true. So when you have the less than, greater than, or at least, or at most, just kind of think about it and see if it makes sense. All natural numbers. So when natural numbers are the ones when you learn to count. When you're little, we don't generally start with 0. We say like 1, 2, 3, and then we increase. So natural numbers start at 1 and they go, on forever. And then when we're little, we don't talk about decimals with little kids. We just start with like 1, 2, 3. All natural numbers not greater than 8. So greater than 8 would be what? Let's just think about that for a second. Don't worry about anything else. Greater than 8 would be 9, 10, 11, and so forth. So the numbers need to be not greater than. So not greater than would be less than 9. And it's natural numbers, so we start with a 1. So 1, 2, 3, 4, 5, 6, 7, 8. Everybody's there. So this is a true statement. Now, if the number 4 was missing, then it would be a false statement because it would not be all the natural numbers that are not greater than 8 or less than 9. Okay. And this notation is a little weird. It's X, and this little line means such that. X such that X is an odd integer. So it's odd. And it's between the numbers 44 and 56. This line underneath the inequality symbol means it includes 44. And again, because there's a line underneath it, includes 56. Okay, it's an odd number. So we're only looking at the odd numbers. So 45, 47, 51, 53. All right, so are all those numbers in there? 45, 47, 49, 53, 55. We're missing 51, so no, it's not true. All right, so we need to fill in with it's a subset or not a proper subset. So just subset or not a subset. All right, so is -4 in here? -4 is in here. -1 is 8 in there also. Yes, so all three of those in there, all three would have to be in there. It is a subset. If it only had like the -4, -1, but the 8 wasn't on the right, then it would be not, it would be this scenario. Okay. This is A, this is set A. And what this is right here, you may or may not have seen it before. We use it for no solution. It's called the null set or empty set. It looks like this. There's nothing in there. And the null set is a subset of every set. Okay. So if we were to go up here, this is also a subset of this U. Sorry, not A, of U. Okay. So the null set, that's the 0 with a line through it like that. That is a subset of every set. Okay. Find the number of subsets of the given set. So there's a general formula. It's 2 to the n power. Okay. Where n is let's see how we word that. N would be number of possible numbers, number of numbers. All right, so x, such that x is an integer strictly between 0 and 4. So if it's between 0 and 4, does it include 0 and 4? No. So that's the numbers 1, 2, and 3. Those are three numbers. Okay, it could say between 5 and 9. If it said that, that would be just numbers 6, 7, and 8. And that would be a total of three numbers. So this is going to be 2 to the third power. Okay, so we have 2 times 2 times 2. And you can put 2 to the third in your calculator. So that's going to be 8 subsets. All right, same thing here, 2 to the n. And we have 1, 2, 3, 4, 5, 6. So we're going to have 2 to the 6th power. Again, just put that in a calculator. I got one in my hand. I'm actually doing it right now. The 6th power. All right, 2 to the 6 is 64. So there's 64 possible subsets of these letters. Okay, it could be just U and V. It could be U, V, W, X, Y. You could do a tree diagram, but it wouldn't be too bad with this up here with the numbers 1, 2, and 3, but with all these letters, it would get pretty big. because you would have 64 possible outcomes. All right, what else we got? All right, and that is it for section 8.1.